This module has given you a better understanding of how to best use the task parallel library to construct powerful operations. As you further explored the methods provided by the task parallel library, you learned about the continuation, how to configure it, and combined all of this knowledge to build something that ultimately gives your users a better experience. You learned how to start multiple asynchronous operations that execute in parallel. This allows the application to load data simultaneously, which increases the performance of the application. You introduced the method task.whenAll to add a continuation that only executes once all of the tasks completed. This provides a task that will be marked as completed when all of its referenced operations are done. We also introduced task.whenAny, which provides a way to retrieve the task that completes first in a list of referenced operations. Then you saw how to introduce a pre-computed result. We can construct a task without running anything asynchronously with a predefined result on that task. This by using task.fromResult, which is often something you'd use in situations where the interface you're implementing requires a task to be returned, but you might already have a static value that you want to return without having to run anything asynchronously. You could also construct a task that is marked as cancelled or faulted. This would be appropriate in, for instance, tests. We introduced task.fromResult in a mock object that allows us to work with an in-memory collection. This ensured that we didn't have to call the backend API each time we ran the application or a test. This clearly speeds up the development process, and for the situations where the API invocation might cost money, this is a really good alternative. You then introduced a way to process tasks as they complete. This allows you to start multiple tasks that run in parallel. As soon as a task completes, you'll have a continuation on that task to be able to handle the result for that operation. With this, we explored a way to aggregate the result of all the operations using a concurrent bag. This thread-safe approach lets us populate the application with information as soon as it's available. Finally, we continued to talking about the continuation. You added configure await to tell the awaiter to avoid marshalling back to the original thread. Doing so allows the code to execute faster because it's not required to wait for the original thread to be available. You found that configure await only affects the current asynchronous method where it's being used, as well as the fact that it's no longer necessary in ASP.NET Core and later. By now, you've got a good idea of how to introduce a task, the async and await keywords, controlling and introducing a continuation, as well as how to follow some patterns to build better performing applications. You are now ready to start looking at some more advanced topics. Continue to the next module, which will take your asynchronous programming to the next level.